Welcome to the next edition of the Reimagine Mobility podcast series. I'm here with Faisal. Faisal leads our software and controls group at Mobility Technologies in the US. Faisal, thanks for joining me today. You do software and controls. Lots of people think of different things when they hear software and controls. Explain to us, what is software and controls? At least software and controls at AVL that you're leading, right? So let's start with that, maybe.
Thanks, Stephan. Our department is software controls and systems as well. And so essentially we have two teams. The systems team looks at the high-level system requirements, architecture, development, design, as well as supporting the verification and validation. Whereas the controls team is looking at the software level requirements, architecture development, developing the software components themselves, integrating and supporting all the testing, mill, sill, hill, and in the vehicle.
Mm-hmm. When you talk software, I mean, to some guy that maybe, to my son, that would mean, video game software. To somebody else, it might be, oh no, you're in the mobility space, it's got to be artificial intelligence, and at the very least, machine learning type stuff. Give us a little bit of a base there to understand.
So it's moving towards more artificial intelligence as well. And so we have all sorts of advanced physics-based approaches and artificial intelligence approaches, big data, and traditionally software, there were higher requirements for software to be more safe and more real-time for controls. And nowadays, there is higher requirement for it to become more flexible, ready for the future use, for more ADAS, AD, for higher level of connectivity, for domain controller kind of architecture, and infotainment, high requirements for infotainment. So software is becoming, more and more complicated. I mean, it's true for all electric and electronic architecture, which is becoming increasingly complex because higher number of vehicle functions, evolution of hardware, software functions, network communication, and connectivity. So really the challenging applications are more in terms of the next generation of electrification. That also includes the ADAS, AD, and connectivity, and more user interface. And there are many different areas which are making it even more complex, is because the architecture itself for software plays a big part, and we also need backward compatibility. So we still want the older software to work. We need a framework that supports evolution at the same time backward compatibility. So that's what makes it more challenging.
And keep up with all the new technologies and new functions and features people want, or car manufacturers demand to give to their customers, right?
Yeah.
So if we take that, then you feel like your department is the most important department within AVL, software and controls, because everybody talks about the software-defined vehicle, right? Everybody thinks that in the future, a vehicle is just software. Now, that's not the case, otherwise you couldn't sit in it. Software is not tangible, but do you feel like you lead the most important department within AVL?
It's pretty important, and
but not the most important? You're avoiding the question there?
I mean, there's a lot of other things. There are different pieces of the puzzle. They all need to come together to create a product.
Sure.
And we are all about offering effective solutions to solving the challenging aspects of the mobility in the future. And software and controls plays a very big part in it. Everything is about controls. The things are becoming more complicated. There is more autonomy. So controls and software, absolutely. It's definitely very interesting.
Give me an idea how software development or controls development, just call it software development for the moment, for simplification reasons. Tell me how software development has changed over the last, let's say, 10, 15 years. When I first started in the space, right, 25 years ago, it essentially was you write software in, I don't know, Pascal maybe even, right? And then C++ comes up, or BASIC maybe still around, lots of different things. But there was not that many what we call today a tool chain. There wasn't that many tools in your tool chain that you could use, right? And then suddenly you have hill systems where you can rapidly test, or sill systems where you can rapidly test your code and your software. How has the whole software development space changed? Not only, again, new languages or big data or artificial intelligence, but also from the tools that you use.
Right, no, absolutely. It's changed in every aspect. So as you mentioned, the one aspect is the actual language or actual the program that you use. So traditionally, we've been working on the embedded code a lot. Now we are more into the higher level languages like model-based environments like MATLAB, Simulink, ASCII. So that has evolved, and it is a lot easier for programmers and software developers. On top of that, there are a lot of standards that are in play now that were not there before. So that makes software higher quality, more reliable, and easier to develop, easier to integrate, and easier to maintain. It's very important that we have the tool chain and the processes together with the software. The software on its own, it doesn't make that much sense because you will not be able to maintain it, update it, change it without the tools and the processes that go with it.
Okay. So that ties into a little bit my next question I have. What are the three, let's say, major mega trends in software development for the mobility space, right? Is it cybersecurity? Is it functional safety? Is it automated code generation? Is it AI? Is it the process of CMMI? Is it the tools and the interchangeability that AutoSAR brings? What are in your opinion, the three major mega trends in software development for the mobility space?
So we are seeing a lot of, so the main applications that we are working on and we see a lot of growth is higher degree of electrification, ADAS, AD, connectivity, and infotainment, higher user experience. And within the software areas, what's happening is we are seeing a lot of multi-core, parallel apps, high bandwidth communication, and domain controls. So the overall architecture of the EE systems is evolving, and AutoSAR is one part of it, is one tool to manage the complexity of this EE system. It also promotes software reusability, and it also promotes standardized interfaces, better calibration efficiency. But it's not very straightforward. What it really takes is a holistic approach, and that essentially means model-based systems engineering, expertise in controls and functional safety, as you mentioned, and knowledge about the hardware, how to migrate the legacy code to the newer standards. So it's a complicated task, but yeah, those are the major trends.
So you talked about multi-cores, different types of parallel computing, different processor architectures. It sounds to me it's all about speed again. It's all about how can we go faster, right? So we need to develop faster, but now we also need to faster crunch data because the vehicle is getting much more complicated and having much more sensors that are now being used to control the vehicle.
Yeah, it's about speed. It's about the higher expectations that we have from our vehicles. Mobility is becoming more complicated, and that takes more speed, more efficiency. Higher computing power, higher memory, and so electronics is also evolving at the same time, and a lot of things that we could not imagine possible, like this degree of artificial intelligence is possible now.
Would it be true to say that in electronics, let's move away just for a second from software and go to the platform that software runs on, which is microcontrollers? Is it fair to say they get faster and at the same time from a footprint, from a physical size smaller as well?
Absolutely.
Faster and smaller.
Comparatively. And I think our expectations, our demand is also increasing maybe even faster than the evolution of the hardware.
Your opinion, mechanical, electrical hardware, or software? Which of the three is the most important?
That's a tough question.
We got no mechanical or electrical hardware guys in here, so if you want to say software, that's fine. But it's always a debate, right? Because the software guy says, without me controlling your mechanical stuff, you're not going to move anywhere.
Right.
The electronics hardware guys are saying, well, that's great software, but without me giving you a place where you can reside, nothing goes. The mechanical guys said, this is all fantastic, guys. You guys can have the best code. If I don't have the mechanics that the wheels turn, what are you going to do? So
I would say they are equally important. Honestly, they are all pieces of the chain. Without any of them, the whole product will not exist. So.
So if you talk about equally important, and let's say I'm a student that just graduated from high school, I'm going to go into college, and I'm thinking about mechanical engineering, that a lot of at AVL have, mechanical engineering degree, or software engineering. What would you advise them? Because the industry right now is telling them everything is going to be software, right? In the mobility at least, right? Software. That's the only thing you read is about software. You don't read mechanical. But what advice would you give me?
I would say it's what's your aptitude, what you'd really like to do. And, follow your heart, and, that would be the best field, whether it's mechanical, whether it's electronics or software. I was always interested in controls and software, and, I really like working in this area, and I'm passionate about it. And I would say wherever your passion is, you should go into that area.
Instead of a particular field.
Right, yeah.
If you look 5 years down the road, staying on that topic for a moment, if you look 5 years down the road, do you see yourself faced with a challenge, we don't have enough software guys? Because everybody says, my passion really is mechanical, how things move, because I can touch it, I can feel it, right? Or do you see yourself in a situation where you have plenty of people, because now everybody jumps into software, right, and comes out with software degrees, and the mechanical guys are suddenly struggling. What do you see in 5 years?
I absolutely see that. I think everybody's going into software and systems, and we are forgetting that the mechanical is a big part of it, and it always will be there. So we will get those cycles. I think you are absolutely right. Too many people are going towards software. We will have a shortage in other areas.
Yeah. If all the different areas that you're supporting, let's say in 3 or 4 easy buckets, it's traditional powertrain, so diesel and gasoline engines, electrified, so pure battery electric vehicles or hybrids, and within that again, e-motors, inverters, batteries, and the third one may be vehicle controls. You mentioned ADAS, you mentioned infotainment, telematics. Which one of these 3 or 4 that I just mentioned has the most complex software in it to develop? Not necessarily, I'm not talking about it takes, 200 people versus 20 people to do one thing. That's complexity, but it's also more code, more lines of code. But what's the most complicated software to write?
I would say ADAS 80. A lot of the problems with the traditional or conventional engine transmission have already been solved. Of course, there are more challenges ahead. Same with electrification. There has been work going on for a very long time. But ADAS 80 is relatively new field, and it requires another degree of complexity. And so, sensors and perception and, all different algorithms that are interacting with each other. It's another degree of complexity.
How important is it for a software guy? Let me phrase it differently. What's the best software engineer for you? A guy or a gal that comes from a mechanical background and turns himself or herself into a software person? Somebody that comes from a purely software background, or somebody that comes from a, let's say, mobility systems background that has a really good understanding of how different pieces interact with each other? What is your best software person out of those three?
So our typical and the best software people are coming from the electrical and electronics background, with either computer science or having some understanding of what the electronics is really like and what are the microcontrollers and different architectures. But honestly, we have had people from all different backgrounds, and we have had people from chemical engineering, mechanical engineering, law and medicine, and mathematics. We have had people
Math guys,
math guys, they once they get into software and they start liking it and it becomes their main field. So yeah, it's really cool.
How good would a software and controls person, how good would a person fit into your software and controls organization that comes from a background, maybe they've never driven a car, they don't have a car because they lived, let's say, downtown New York, and they worked on apps, software apps, but they clearly have the skill to also do embedded coding, but they don't have no relationship with a car. Is that a problem until they learn it? Is this not a problem at all, or is this a challenge for you to? It
is a little bit of a challenge, and when we say software and controls, there are so many different areas. There is aerospace, there are other fields, there is industrial controls and software, but the domain knowledge is extremely important. So we really look for people who know how an engine works, how a vehicle works. That I think really brings in the perspective that we're looking for.
Brings value because somebody understands how it's supposed to work. And, Okay, maybe last question. What is something in your space today that you did not think possible 5 years ago, as it relates to software?
So my background is artificial intelligence in controls, and I've done a lot of R&D work. I never thought that it will make way into production that fast. That is really fascinating.
And you see it only in the ADAS or autonomous space, or you see it also in electrification?
I have seen it in conventional engine and transmission controls as well. And we have done many projects for customers where we've designed software that includes the artificial intelligence for conventional electrification as well, vehicle level, supervisory level controls, and of course ADAS AD.
Okay. Thanks, Faisal, for your time and insight into software and controls. And he didn't want to say it, but I think software is the most important piece here. So thank you very much. Thanks for tuning in.
Thank you.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.